Hello guys, welcome back to this game theory series. Uh, this is an extension of the concepts that we discussed so far on non-cooperative games. So we have seen non-cooperative games of two types: simultaneous games and sequential games. Simultaneous games are represented using normal form representation. Sequential games are typically represented using game tree representation. And all the games that we have seen so far were one-shot game because they were played only once. Now here we see uh, an introduction to repeated games. When a one-shot game gets repeated over multiple times, how the player's behavior changes. So a good motivation for repeated game is reputation. It is intimately bounded up with repetition. So firms, both small and large, develop reputations for product quality and after-sales service through dealings with successive customers. Retail and service chains and franchisees develop reputation for consistency. Individuals also cultivate their reputation through their personal interactions. So the definition of a repeated game. So the reputation actually gives motivation to study repeated games. When a game is more than played once by the same players in the same roles, it is called repeated game. The original game, the one-shot game that we play is called as kernel game. The number of rounds count the repetition of the kernel game. The repetition may last for a fixed number of rounds or be repeated indefinitely, where we do not know when it will end. So games repeated a finite number of times. There are two cases to consider. The kernel game has a unique solution and kernel game has multiple solutions. For example, Prisoner's Dilemma played over multiple times is an example of a kernel game with unique solution. Battle of Sexes played for multiple rounds is a kernel game with multiple solutions. So let's take two-stage Prisoner's Dilemma. The two players play the following simultaneous move game twice. The outcome of the first play is observed before the second play begins. The payoff of the entire game is simply sum of the payoff from the two stages. That means we value history equally, so discount factor is 1. So we can represent it this way, and this is an example of a representation using both a game involving both sequential and simultaneous steps where player 1 and 2 play simultaneously, then sequentially player 1 and player 2 play simultaneously again, and we can show the table along with the sum of the payoffs in each iteration, and this is a game tree we can analyze to go back and find out what will happen. Okay. There could also be infinitely repeated Prisoner's Dilemma. The game is repeated infinitely. Suppose that the player play C, C, 3, D, D, C, C, D, D on every alternate round. Then the naturally given this table, C, C will lead to 3 as a payoff, followed by 1, 3, 1, 3, 1, etc. So overall payoff can be determined as a sigma of E of ui to the power x. There is also a concept of future discounted reward. That means after some iterations, maybe the history is not very important. So we can put a discount factor delta to give less weightage to the history. So the near history is more important than the far history, which makes sense, right? So then we can represent the values accordingly. So please pause for a minute and look at the example written here. There are also possible strategies for the players when they play in repeated games. One example is tit for tat. Cooperate in the first round. In every later round, do the same thing as the other player did in the previous round. So if the other player defect, I will defect. Tit for tat. When he changed to cooperate, I will cooperate. Like that. Trigger strategy is cooperate as long as everyone cooperate. Once a player defects, defect forever. Like there is also a concept of grim trigger strategy, which is like when he defect, I will give him a chance again, up to some theta times. And after that, my patience is lost. After that threshold, I will defect forever. That's a problem to think. The race to 15 game theory puzzle. Alice and Bob takes turns selecting cards numbered 1 to 9 without replacement. Alice goes first, then Bob picks a remaining card and so on. The first player to make a set of 3 cards then adds up to 15 wins the game. Does Alice have a winning strategy? Pause the presentation, the video, try to work out a strategy and then proceed.
Hi, this is Presh Talwalkar. In this video we're going to discuss a game theory puzzle called the Race to 15. Here are the rules to the game. There are 9 cards numbered 1 to 9. 2 players, Alice and Bob, take turns picking up cards. So what that means is that Alice will pick up the first card, then Bob will pick up any of the remaining cards, then Alice will pick one of the remaining cards, and so on. The first player to collect a set of 3 cards that add up to 15 wins the game. The question is, can Alice, who goes first, guarantee a win? I want you to think about this game, give it a try, and see if you can solve it. When you're ready, keep watching for the solution to the game. So the difficult part is trying to figure out the sets of 3 numbers that add up to 15. The trick is to use a 3x3 magic square. In a magic square, every row, column, and diagonal will have the same sum of 15. So I could just write out the magic square with the numbers 1 through 9, but I'm going to show you how you can generate this. It's a method called the upright or down method. It starts out by writing a 1 in the middle of the top row. Then what you want to do is go up and to the right to get the next number. So here we go up and to the right, and we need to wrap around. So this is where we write the number 2. To get the next number, we go up and to the right. Again, we're going to need to wrap around. And this is where we write 3. We again go up and to the right, but this time we're blocked because this square already has a 1. So when we're blocked, we go down. So that's where we write a 4. And we're going to keep on applying this rule of going up and to the right to write the next number and continue to fill out the square. So in the center square, we have a 5. In the upper right-hand corner, we have a 6. Now we're going to try and go up and to the right. We're going to need to wrap this around. We're once again blocked, so we need to go down from where the 6 is. That's where 7 will be. And we continue filling it out. We'll figure out where the 8 is by going up and to the right. And the 9 will also be up and to the right of 8. As you get a few of these in, you can also fill them out just by knowing that the sum of each row or diagonal or column will be 15. So now we have a magic square where every row and column and diagonal sums up to 15. And those are the only sets of 3 numbers that add up to 15. So let's try and solve the game. So what we'll do is we'll imagine when Alice picks a number, we'll visualize it on this 3x3 grid. And we'll mark her spot with an X. So let's say she picked a 5, we put an X in the center. Whichever number Bob picks, if he picks an 8, we'll put an O in that square. So having a sum of 15 means getting a 3 in a row, because the only way to get 15 is to have one of the rows, columns, or diagonal. And that's the insight. This game is exactly like tic-tac-toe. So wherever Alice goes and Bob's go, we're alternately picking X's and O, both players trying to get 3 in a row. Since tic-tac-toe ends in a draw, this game also ends in a draw. Did you solve the puzzle? I hope you liked this video. Please subscribe to my channel. You can support me on Patreon for exclusive rewards. catch me on my blog Mind Your Decisions, on Twitter at Presh Talwalkar, and you can get my books listed on my website.
So the outcome can be searched on Google or YouTube. It is essentially the magic puzzle tree, a matrix where the rows and columns can lead to sum of 15, and the solution is easily possible with that. There are different ways of finding answer. This is one way of finding answer. There is also a related concept of non-cooperative games called coordination games. By the way, I'm not discussing repeated games further. I intend to give only a very brief description of repeated games. So coordination game is where both of the players need to coordinate each other to decide on something. So consider the following problem. A supplier and a buyer need to decide whether to adopt a new purchasing system. So if they both, supplier supplies a new system and buyer also buys that, there is a good benefit for both of them. Maybe supplier gets a lot of extra money and buyer gets some additional features. And if they continue to use old, there is some profit and some benefit, 5, and the other two cases does not happen. That is why it is called coordinated game. If supplier is supplying only new, buyer cannot proceed with old. Supplier is supplying only old, buyer cannot proceed with new. This is an example of a coordination game. In real life example, we may think of things like, should I choose Windows or Linux, and then what is available in the market for me, and things like that. So coordination game turned out to be a important real life problem. A policy, strategy, adoption, delegation of authority, social norms and rules can also be used. And this only to throw you a light on what is a coordination game. And it's very similar to your non-cooperative game, but with some unique characteristics. With that, let me thank you. Bye.